Thank you guys for coming. It's really awesome to see everyone here and, have my parents come from out of town. Makes me all the more excited today to talk about what I've been up to for the past few years. Before I actually do get talking about those studies, though, I just want to take a quick second to go over how my presentation is going to look. So first, I'm going to take some time to just talk about the basic function of the cardiovascular system and as well what we know about cannabis itself. I'll then take some time just to talk about what we know about the two of those things together before going into the studies that were a part of my PhD here, which looked at how cannabis affects the autonomic nervous system, function of the heart and arteries, and then exercise physiology as well. I'll then give some overarching thoughts and then try to keep it together while I give out some well-deserved thanks. So just to get everyone on the same page here, I wanted to simplify the cardiovascular system a little bit. The reason being that today I'm going to be talking about function of the different tissues and aspects of the system itself. But I think in order to appreciate what those tissues are doing, it's important to understand what the fundamental roles of the system are. One of them is to deliver oxygen to all of the body's tissues. And this is done so via the blood, which is pumped by the heart through the arteries. Now, since blood is a fluid, the physics dictating its flow can be boiled down to relatively simple terms in that the flow of blood is dependent on the pressure gradient driving the flow and is opposed by the resistance to the flow created by the vessel in which the blood is flowing through. Now, this relatively simple relationship is important to appreciate because when we talk about different aspects of the cardiovascular system, we can generally think of them as affecting one or more of these variables, so that our brain can remain perfused at all times, and so that we can do tasks like dynamic exercise. Really, what the studies I'm going to be talking about today look at how cannabis impacts different aspects of the cardiovascular system to perform these tasks. So more specifically, what we'll be looking at today is the autonomic nervous system, the heart itself, arterial stiffness, and as well vascular endothelial function, which refers to the innermost layer of cells within the arterial wall. Now, the reason that we selected these tissues are a fewfold. One, they're all important for maintaining homeostasis. The decrement of their biological function is implicated in the progression of different cardiovascular disease, and as well, they're acutely affected by things like smoking and exercise. Now, because all these tissues are also required to work together to do dynamic exercise, we'll also test exercise capacity within these experiments. Now, when it comes to cannabis, what we know about it is that at the moment, it's the most used recreational substance in the world, exclusive of alcohol. But beyond its social relevance, it's also biologically relevant because the receptors through which the main cannabinoids within cannabis, CBD and THC, act are widely found throughout all the body's different tissues, and in particular, the cardiovascular system and nervous system. Now, in addition to these receptor systems, cannabis is also often smoked, similar to cigarette smoking, which we know to be one of the most detrimental behaviors to cardiovascular health. But further complicating the picture is the fact that cannabis isn't always smoked and it can be inhaled by other methods, such as vaporization, which represent a smoke-free consumption method, which might be particularly important given the fact that we know that smoke itself is bad for our cardiovascular tissues. Now, whether or not cannabis affects the risk of cardiovascular disease has been the topic of investigation by a number of different research groups. And when you look at the literature, what you'll see is that there's a mix such that some suggest that it does increase the risk of cardiovascular disease, while almost a near equal number suggest that it does not. Now, this equivocal body of literature has generally led professional societies like the American Heart Association to indicate that there's a need for basic research into both the short and long-term effects of cannabis on the cardiovascular system. So the scope of my PhD was to understand how cannabis affects cardiovascular physiology. And we approached this question by looking at how it affects the biological function of different cardiovascular tissues, both under resting conditions and in response to exercise, while trying to also pay attention and get some idea of how different cannabinoids and inhalation methods affect this response. Going to the experiments we did now, what I'll look at first is how cannabis affects the autonomic control of the cardiovascular system. For those who are less familiar with this physiology, the reason that we care about the autonomic nervous system when it comes to the cardiovascular system is because it's responsible for innervating the smooth muscle cells within the vascular wall and as well the heart itself. Now, through these innervations and in particular the Oh, I'm sorry, I think the clickers.
Think it might.
Yeah, it's the Zoom. John, do you mind just admitting Brittany there? The reason that, sorry, I'll jump back in here, but the reason that we care about the autonomic nervous system, and in particular, the sympathetic nervous system, is that these innervations to the vasculature in the heart have different effects. The first, for example, being that the sympathetic nervous system can cause vasoconstriction of the arteries, which can result in vasoconstriction and an increase in resistance throughout the whole system. And a sympathetic innervation to the heart can also increase heart rate, which can increase total flow through the cardiovascular system. And again, these variables are important because they can be each used to modulate arterial pressure so that we have our tissues being perfused at all times. When it comes to cannabis, what we've known now for decades is that in a dose-dependent manner, it increases blood pressure and heart rate. And the general understanding and consensus up to this point has been that it does so via an activation of the sympathetic nervous system. But importantly, what we don't know up to this point is whether or not this cannabis inhalation is also associated with an increase in sympathetic activity towards the vasculature. So in collaboration with Phil's lab, we were able to test this question using a technique called microneurography, which involves inserting microelectrodes in the common fibula nerve of the lower leg. In this technique, we then position those electrodes near sympathetic nerve fibers to record their activity, which we call muscle sympathetic nerve activity, or MSNA for short. So using this technique in our experiment, what we did was we essentially located an appropriate MSNA recording site for up to 60 minutes, after which we did a baseline recording for 10 minutes where we recorded MSNA and blood pressure and heart rate using finger photoplethysmography before inhaling predominantly THC containing cannabis. After this intervention, we recorded for another 10-minute period. Now, as a reminder, we hypothesized that this activity would increase based on what we know happens in the heart. And this increase in MSNA would be represented by either larger or more frequent bursts of sympathetic activity, demonstrated in the neurogram here. So you can imagine our surprise when after cannabis inhalation, we saw a near complete disappearance of this MSNA in the 10 minutes post. Now, while this is just one neurogram from one participant, what I will show you is that at the group level, we also observed this large decrease in MSNA, and with the individual lines here demonstrating that this happened in every single participant we tested. Now, fortunately, we think we can explain this finding with the knowledge of something called the arterial baroreflex, which is a neural reflex loop responsible for maintaining blood pressure at rest. And what's important to know about the arterial baroreflex is that it can adjust different physiological outputs to control variables like flow and resistance, such that blood pressure is maintained at an appropriate level to ensure our tissues are perfused. So in the case of THC containing cannabis, what we believe to be happening is it's increasing flow throughout the system by an increase in heart rate, requiring a reduction in MSNA and therefore resistance in order to maintain pressure at an appropriate level. Now, for this hypothesis, fortunately, our data also supports it. When we looked at heart rate, what we saw is that once again, heart rate increased in every single participant we tested. But importantly, when we plot this change in heart rate against this change in MSNA, what we can once again see is that this reduction is related such that the participants with the biggest increases in heart rate have the biggest decreases in MSNA. Now, what this would suggest to us is essentially that the arterial baroreflex here is acting to reduce MSNA and maintain blood pressure. Where things get particularly interesting is the fact that when we measured mean arterial pressure, we did still see it slightly increase. In other words, the baroreflex isn't working completely perfect. And we can get a sense of how well it's working by constructing these baroreflex slopes, which here illustrate how much a change in diastolic blood pressure is associated with a change in MSNA. But the idea here being that a steeper slope represents a greater change in MSNA for a given change in blood pressure or a more sensitive baroreflex. Now, when we construct these slopes after cannabis inhalation, what we see is a significant attenuation of this relationship, suggesting that once again, a given change in blood pressure is associated with a lower change in MSNA, or it's made the baroreflex less sensitive. Now, because we know that the baroreflex can also manipulate flow to maintain blood pressure, we can quantify its sensitivity using heart rate as well as MSNA. And again, we know this because changes in arterial pressure can be responded to by changes in sympathetic activity to the heart, resulting in changes in heart rate. So we repeated this experiment, but in addition to testing a predominantly THC containing cannabis, did so with a CBD predominant cannabis. Looking at our results here, when we constructed these cardiac baroreflex sensitivity curves, we saw similar findings in that THC containing cannabis attenuated this baroreflex sensitivity, in that a given change in blood pressure was associated with a smaller change in heart rate. In contrast, when we looked at CBD, we saw no such relationship. So from these experiments, what we can conclude is that it appears MSNA is reduced by cannabis inhalation, and this is likely due to a baroreflex mediated inhibition of MSNA in response to changes in heart rate. As well, it appears that cannabis containing THC reduces sympathetic and cardiac baroreflex sensitivity. However, CBD containing cannabis has no effect on the latter. So I'll now move into our studies looking at how cannabis affected the function of the heart and arteries themselves. I don't think I need to spend time telling everyone why the heart and arteries are important for the cardiovascular system, but I will justify why we looked at the specific aspects of their function that we did, in that we looked at arterial stiffness, the vascular endothelial function, and as well the function of the heart itself. Now, our reason for selecting these were because arterial stiffness is an important indicator of how blood pressure is dampened with each heartbeat. The vascular endothelium has the ability to regulate arterial tone and therefore affect pressure and flow and resistance. And the heart itself is also responsible for generating pressure and flow throughout the system. Now, I'll remind you that importantly, each of these or deterioration of function in each of these is associated with the progression of disease, and they can be manipulated by things like exercise and smoking. Now, prior to these studies, there was some knowledge about how cannabis might affect these different outcomes. So for example, our group and others now have demonstrated that cannabis users demonstrate greater arterial stiffness than non-users at baseline. Matthew Springer's lab from UCSF, who I've been fortunate enough to work with, has demonstrated in a rodent model of vascular endothelial function that both aerosol, equivalent to vaporizing, and smoke reduce vascular endothelial function. And as well, studies from now decades ago demonstrate that both systolic and diastolic cardiac function is reduced following cannabis inhalation. Now, while I think all this literature is extremely valuable, I think there's some important limitations that are worth addressing. First, I'll pick on myself and say that in this study, we weren't actually able to administer cannabis, so we weren't really testing the effects of cannabis smoke directly. As much as I think of the Springer lab experiments, I think it's important to acknowledge that rodent models don't always perfectly represent human physiology, so it's worth testing in human. And as well, these studies of the heart were done in the 1970s, where echocardiography was simply not in a place that it is today. So we sought to overcome each of these limitations, first by building a custom-made smoking chamber within our lab and getting all the necessary approvals to actually use cannabis with participants in the lab. Then also using vascular ultrasound to measure endothelial function in the brachial artery. As well, we could use more contemporary methods of echocardiography to more comprehensively characterize cardiac function after cannabis use. To give you a little bit more specific details about what we did in these experiments, we measured arterial stiffness using a technique called tonometry, which involves using these pressure sensing pens to measure how fast pulses are traveling down the length of the vasculature. With the idea here being that faster pulses indicate stiffer arteries, which is related to disease risk. We also quantified vascular endothelial function, as I mentioned earlier, using ultrasound with a technique called flow-mediated dilation, which measures how much the brachial artery can dilate in response to a change in blood flow, with the idea being that more dilation indicates better endothelial function. Finally, we used a more sophisticated ultrasound device to comprehensively characterize cardiac function, once again using more contemporary and updated methods than what was available to the investigators in the 1970s. And we did so after 3 different cannabis conditions, with the first here represented by this code VTHC, which indicates that cannabis was vaporized and predominantly contained THC. We also had participants smoke that same cannabis, and then finally use the vaporizer to inhale the CBD predominant. cannabis that we had. The logic behind choosing each of these conditions was that it could allow us to compare the effects of cannabinoid and smoking method or inhalation method directly. Looking at our results here, what we saw was that arterial stiffness was elevated on average after cannabis use, which is indicated here by the main effect of time. Now, what I'll note is that although this is the main effect of time, these increases were very, very slightly greater in our THC-containing conditions compared to our CBD-containing condition. In contrast, endothelial function was not affected by any of our cannabis inhalation conditions, which again, I'll note just differs from the previous work done by the lab. Moving into cardiac function, we can look at both systolic function of the heart, which describes how the heart is ejecting blood, and diastolic function, which describes how the heart is filling with blood. And what we saw when we looked at these aspects of cardiac function was that although systolic function was unaffected by any of our cannabis inhalation conditions, diastolic function was altered at the group level, with decrements in diastolic function being slightly observed in the THC-containing conditions, but not the CBD-containing conditions. I think perhaps most importantly from this study, though, what we can take away is that hemodynamic changes occurred in that blood pressure and heart rate were elevated only in the THC-containing conditions. Now, this is particularly important in interpreting our findings because what we observed is that when we plot our pulse wave velocity, which is our arterial stiffness measure, with systolic blood pressure, we see a significant relationship. And likewise, when we plot diastolic function measures that were impacted with heart rate, what we once again see is significant relationships with this change in function. Now, to us, this suggests that the changes in blood pressure and heart rate are driving these changes. And the reason we think that it's happening this way and not the other way around is because previous investigations which have manipulated blood pressure or heart rate show strikingly similar relationships in these different outcomes. So from this experiment, what we can conclude is that it doesn't appear that cannabis acutely alters vascular endothelial function in humans. However, THC predominant cannabis does appear to increase arterial stiffness and very slightly reduce diastolic function. However, these effects are quite small and likely driven by changes in blood pressure and heart rate. Now, for the final two studies here, what I'll talk about is how cannabis impacted our physiological response to exercise. I'll also take the time to just reintroduce why we look at exercise. And I think it's best done by appreciating this figure here, with this circle demonstrating how much total flow goes through the cardiovascular system at rest. What you'll see is that in an average person, when we go up to maximal exercise, this flow rate, or the amount of blood that needs to move through the system, almost quadruples. And if we look at an elite athlete who can attain even higher work rates than an average person, this can go up to 8-fold. And what I want you to take away from this figure is that clearly to accommodate such a dramatic increase in flow, we require exceptional function from all our different tissues. So we wanted to understand whether or not cannabis affects the response to exercise. And we did a number of different experiments using the same cannabis conditions I introduced earlier. But this time what we did was we measured exercise and cardiovascular function after those inhalations. We did so by taking cardiac images during supine cycling, so while participants were lying down, and by measuring blood pressure during a 20-minute maximal effort cycling test where participants were put on the bike and told to maintain as high an output as they could for a 20-minute period. We also looked at cardiovascular function in the post-exercise period by having participants do that 20-minute maximal effort and then measuring arterial stiffness, vascular endothelial function, and cardiac function afterwards. To give you a sense of what this looks like, we have a participant here on the bed while they're having their heart scanned, and we would have them cycling here so that their heart rate reaches 100 beats per minute while we take images. As well in the video here, you can see we'll have a participant going essentially as hard as they can while we're measuring blood pressure from the arm. And I'll just take a quick second to acknowledge that neither of these images are from my cannabis studies. They're from studies that I was lucky enough to work with Alex and Kyle, so quick shout out to them for that. Now, diving into our results here, what we saw was that when we looked at both diastolic function of the heart and systolic function of the heart during exercise, what we saw was that the change from rest to exercise was not different in any particular condition, which in the figures here is indicated by the stippled bars, which represent the exercise response, generally looking the same across all our different conditions. Likewise, when we plot blood pressure throughout the 20-minute time trial, we see that there's generally no effect of any cannabis conditions on this blood pressure response. Moving into our results in post-exercise cardiovascular function, what we saw was that arterial stiffness and vascular endothelial function were generally unchanged by all our different cannabis conditions, and for the most part, cardiac function was not different for exercise. However, we did note that when we looked at pulse pressure, which can be described as the difference between systolic and diastolic blood pressure, there was a significant elevation in the post-exercise period when THC-predominant cannabis was smoked prior to exercise. And while this sort of represents a bit of an isolated finding from our functional measures, I do think it's notable. The first reason being the fact that pulse pressure is a significant predictor of cardiovascular disease risk. And from an acute perspective, there's evidence to suggest that increased pulse pressure might contribute to things like carotid plaque ulcerations, which could be a precipitating event for cardiovascular events, which are described as heart attacks and strokes. Now, why this might be particularly relevant is that there's already literature suggesting that cannabis use might represent a trigger for these cardiovascular events. And for quite a long time, we've known that the risk of myocardial infarction and stroke are already elevated in the post-exercise period. So this blood pressure finding might represent sort of an interactive mechanism by which these two factors could increase the risk of cardiovascular events. However, that is speculative. So from this study, what we can conclude is that it doesn't appear that cannabis use impacts exercise and cardiac function or blood pressure. But post-exercise pulse pressure is elevated when THC-predominant cannabis is smoked. While that does occur, post-exercise cardiac and vascular function are not impacted. For this final study, I'll keep the rationale pretty simple. As Jamie kind of introduced earlier, I've been a member of the Human Performance and Health Research Lab for about 6 or 7 years now. So I think naturally, both of us were interested in understanding how cannabis affects actual exercise performance. Now, like any good research question, we weren't the only ones who were interested in it. And I'll share a couple studies from other groups who were. The first here was a group that administered an oral THC product, so an edible product, prior to doing the same 20-minute cycling exercise test that we did. And what they demonstrated was that 20-minute cycling performance was not impacted by this edible THC product. In a similar design, an oral CBD product was administered to individuals who were then asked to do a time to exhaustion running test, and there was no differences demonstrated with the CBD condition. And as well, a similar CBD product showed that there was no differences in 10-minute cycling performance. Now, what I will note is that all these studies use edible products, none of them looking at inhalation, and likewise, none of them directly compared THC and CBD. So while they're informative, there still remains much to be learned. So with our study, we wanted to address some of these knowledge gaps. And we did so by introducing the same cannabis conditions that by now you'll be familiar with, but asking participants to do 10 minutes of submaximal cycling, followed by that 20 minutes of maximal cycling after that submaximal period. We, and when I say we, I really mean Riley, then asked perceived exertion every 2 minutes throughout the exercise bout. And then we also measured heart rate throughout, and as well measured metabolism using indirect calorimetry. Looking at our results here, what we observed was that despite the fact that THC is a psychoactive drug, there were actually no differences in perceived exertion or how hard participants reported the exercise feeling. In addition to this being an interesting finding, it's also important to acknowledge that the fact that people reported the exercise felt the same, this indicated that they were likely trying equally hard in each condition, which is important for parsing these performance results that I'm going to show you. Before I do, I'll just quickly talk about the physiological responses to exercise. And what we noted when we looked at heart rate was that during the submaximal exercise period, both THC-containing conditions significantly elevated exercising heart rate. However, this effect disappeared once they initiated maximal exercise. When we look at VO2, which represents the metabolic cost of the exercise being performed, what we saw was that, once again, there was no differences in maximal exercise VO2. And for the most part, submaximal VO2 was also similar, with the only exception being an elevation in the smoked THC condition. But again, the takeaway here being that for the maximal exercise period, there were no differences. Now, despite that, we did see an effect on performance such that the THC containing conditions reduced mean power output during the cycling exercise, with this effect being on the order of 10 to 20 watts, which for those who aren't cyclists, I'll just note is a significant performance effect that also compares well in magnitude to other nutritional and ergogenic substances that you might use in this context. So from this study, what we can conclude is that it appears some maximal heart rate is increased when THC predominant cannabis is inhaled. And as well, oxygen consumption and exertional responses to max exercise appear unaffected by cannabis inhalation. However, despite this fact, THC predominant cannabis still impairs exercise performance. So now I'll just do a quick wrapping up of what we've learned from all of these studies as a collective, and then give out some quick thank yous. So I think what we can take away from these studies is that it seems clear that THC is likely responsible for most of the cardiovascular effects of cannabis use, more so than CBD. And in a similar vein, inhalation method also appears to not be so important for this response, at least compared to THC. And I come to this conclusion based on the fact that throughout most of our studies, generally the effects we saw between THC and CBD exceeded those observed between smoking and vaporizing. As well, it appears that many of the hemodynamic effects of cannabis, in other words, changes to heart rate and blood pressure, are likely driving changes in the function of different cardiovascular tissues. And as well, it appears that THC impairs exercise performance. However, the physiological reason underlying it is not so clear.